This is what happens when you're the last speaker of the day. You got to wake the crowd up. That's me trying to mimic the sound of construction. So I'm going to ask you to show hands here. How many of you have been woken up to the sound of construction? Show your hands. How many of you have had a hard time falling asleep because of the noise of construction in the neighborhood? How about a hard time studying or a hard time maybe getting your work done? And how many of you just basically feel like the noise of construction is annoying, right? I would be really, really troubled if you didn't. But what's interesting about construction noise is it's actually a very serious issue worldwide, and it actually has a human cost, and it's something we don't talk a lot about. So the World Health Organization published an interesting report about Europe and a calculation that says that 1.6 million, what's called a daily, which is a disability-adjusted life, are impacted every single year in Europe just from construction noise. What that means is there's a measurable impact to the costs in our healthcare system and to ultimately our life expectancy when we're surrounded by noise. And that's because we have stress from that noise, and that stress can actually bring on early incidents of dementia and other disorders. There's a cost to the impact of construction. And that cost is not just about sound, it's actually in all kinds of other areas of making buildings. And that cost is a cost to society and to you and I that we all pay every day. And that's true worldwide. And there's a problem that we're not facing with that cost, which is that those that create that noise actually aren't directly accountable to pay for it. Instead, you and I have to. So I'm an architect, and I'm very proud to get to build buildings that hopefully make the lives of the people I build for better, and also hopefully make the planet better in doing so. And that's the focus of our practice and our career. But I also recognize that every time I make a building, design a building, or construct a building, or during that building's lifespan, there are these indirect costs that are negative cost implications to you and I and to society. Now, the problem is the construction industry effectively are not incentivized today to be able to fix these costs or to innovate to get rid of these impacts and costs to all of us. And they're not incentivized largely because this is an industry that doesn't innovate a lot. Really, we build the exact same way for the most part as we did 100 years ago. Nothing's really changed except for maybe some workplace safety issues. But for the most part, we literally build the exact same way we have for a very, very long time. And that's a problem. And in fact, we're one of the few industries in the world that is in negative productivity. Right? We actually are getting worse year by year by year what we do, and that's because we are innovating in many ways in the wrong places, in the wrong ways, and we're not solving these bigger problems. So for me, about 20 years ago, I got really passionate about the idea of building in wood, and then ultimately, about 15 years ago, wrote a book on how we could build skyscrapers made in wood, and we could build much bigger buildings in urban environments made of wood. And my motivation for doing that, and I gave a TED Talk 11 years ago on the main stage about it, and the motivation for doing so was really about this number right here. 42% is the amount of man's greenhouse gas emissions directly related to the making and operating of buildings. A lot of people don't know that number, and it is really important to remember it. In North America, that number is almost 50%. But 42% worldwide. Now, all of transportation combined, the area where we talk about climate change impact, it just comes about 24%. It comes from the transportation sector. So we talk about it all the time as cars, planes, trains, automobiles. That is cars, by the way, and boats. And instead, construction is a big part of the problem. So our motivation in developing this idea of building with wood at big scales was to offset concrete and steel that are high carbon-intensive materials. And through that TED Talk, we popularized this idea, and we were able to build, our firm was able to build this building, which was the second tall wood building in the world, and the first in North America. And second, just after my good friend Andrew Waugh in the UK built one that was about a meter shorter than this one. It's a little dig on Andrew because he was first. So we built this building, and we were able to measure and prove that this building actually was 88% less carbon dioxide than in its footprint than had we built it in concrete. And we've gone on since to build, as our practice, we only build this way because we very much believe that buildings have to help us address climate change. And we've gone on to build universities, schools, office buildings for high-tech companies, and even museums right here in British Columbia. And in that process, we've also had this unique opportunity to build some very big buildings, and right now we're designing a 55-story tall wood building that hopefully we'll be able to publicly announce where it is in the near future. And the idea was new, right? This is the first new way to build a skyscraper in a century. This is the type of innovation that we needed for climate change. And when we brought it first forward through my TED Talk 11 years ago, people thought we were crazy, or more specifically, people thought I was crazy, and said, this will never happen. This is an industry that doesn't like innovation. It's not going to happen. But it is happening. And thanks in part to the TED community and in part to the volunteers that translate TED Talks, the idea was translated in over 30 languages and has become the single largest conversation in our industry worldwide over the last decade. And the first time we're seeing change. No clapping, I'm going to run out of time. So that's good news. But again, the problem was actually a bigger problem. Because over time, people kept asking me this one question. That's great. Okay, we can build buildings that way. It's a totally new way to build a skyscraper. Great. But they kept asking this question, besides the question of, will it burn down? That's obviously another one. But this question really troubled me. Is it cheaper? And it troubled me because it's absolutely the wrong question. And it's based on the parameters of how we currently measure the cost of buildings. And I believe it's quite incorrect the way or incomplete in the way we measure building costs, and therefore we don't innovate. It's very hard to introduce a completely new way to build when you don't have a lot of experience with it, a lot of competition in the marketplace, there's not a lot of available skill and so forth. So it's very hard to create innovation when the foundations of that skill don't yet exist. And so is it cheaper is challenging. Because on the metrics of how we actually measure costs today, it wasn't cheaper. It is now, and it very much will be based on what I describe in a moment here. But fundamentally, that question of is it cheaper, I believe has been the single most stifling question to all innovation in the construction industry. Because everybody wants it to be cheaper based on today's metric, not on what we're going to talk about in a moment, which is what's called true cost. So first, let me explain how buildings are costed. And this is generally worldwide the way we think of buildings, okay? We have what's called hard costs. And the hard costs are labor, people swinging hammers, and materials, which is, anything that goes in the building. And that makes sense, right? Most of us understand from our own houses that that's what a building is made out of. We also have what's called the soft costs. And the soft costs are a whole bunch of things, including the architects and the engineers, design fees, the permit fees, the taxes, loans from the bank, and other kinds of processing regulatory fees. When you put hard costs together with soft costs, you get what are called project costs, and almost the whole world over, that's basically what we evaluate as what the cost of a building is. And the problem is that's just the beginning of what the cost of a building is. Because we only talk about that, we don't factor all these other factors. The other important issues are, but what is the cost to the planet? What is the cost to society, that noise issue we just talked about? What is the cost in performance? And ultimately, what is the cost from a process point of view? All that together is what we've been calling true cost. And this is a new concept for my industry to think about and to wrap its head around. True cost captures all of these issues that you and I pay for and society pays for that currently the industry doesn't pay for and therefore doesn't innovate to solve. So globally, here's some fun facts, statistics, but the global construction industry in 2023 spent $13.5 trillion. It is a huge footprint, or roughly 16% of global GDP. Construction is a major part of the global economy. It's expected by 2032 that number is going to go up to $24 trillion. So again, it is a huge component of our global economy. I think when you factor in all of those other costs, not just the project costs as we first talked about, but those true total costs, what you start to see is this impact of 3 to 4 times that number, which would make it The single largest economic conversation on the planet that nobody is actually having right now. And that's the problem. We're not talking about it, and therefore we're not finding solutions for it. So let me walk you through true costs and some examples to kind of help you understand it. And probably the easiest one is based on planetary costs, right? When we build a building, it has an impact, of course, and it's a whole bunch of different things: pollution, air pollution, forest loss, landfill expansion, and truthfully, there are hundreds of these. I've just put a few on the table right now. But let's focus again on climate change, because that's the one I started with, and I think it's the one that really is the most existential, important for us to wrap our heads around. So again, I mentioned that 42% statistic, and really it's almost 50% here in Canada and the US. Over the next 20, 30 years, the impact of climate change is expected, and the World Economic Forum gives this number of $1.7 to $3.2 trillion worth of spending to address climate impact. And I think this number is far, far lower than reality as climate is impacting us. If buildings represent 42% of the problem, why are we not putting a direct cost of carbon and other greenhouse gas emissions on the tab of every single building we build by charging for carbon? Every politician will tell you, well, it's far too complicated, but it's not. We all pay for this in our lives already. We are all collectively paying for the impact of climate change, and we'll continue, and our children and our grandchildren will. The cost of carbon should be assigned to every building, because when it is, everybody gets really interested in lowering costs and therefore lowering carbon. And until we do, we're going to really struggle to create the innovations necessary, like the tall wood buildings I just talked about. So the next issue I'll talk about is societal costs. And again, I'm just going to give you examples, but there are a lot of different types of societal costs, including exploited labor and impacts on our healthcare systems, on our mental health, and all these relate back to how we build buildings and how buildings are ultimately used. So these examples, I'm going to just give you two to kind of help really dive in a bit deeper to help us understand. And I'll start with affordability. So affordability is a major topic of conversation in a lot of the world. It's certainly incredibly important here in British Columbia, and certainly through North America. There's an enormous issue of access to housing and affordable housing. And that comes at all different sort of levels, but the most vulnerable population, slowly governments are trying around the world to meet that housing demand by providing housing in different ways. And typically, governments choosing to do so will decide that they want to hire the lowest cost design team and build a building that's as low cost as possible. And their goal there is to be responsible to the taxpayer, and they feel like they're doing a good job. The problem is there's this really important true cost of construction that's not being considered, and it's a really complicated one. And there are many, but I'm just going to give this one as an example, and that's the true cost of dignity. When you ask somebody to live in a very, very low cost, and therefore usually it has less durable materials in it, might be not designed as well, they know that they're in a low cost building. They may not feel a sense of belonging and therefore maintain that place. Well, that's a cost. That building, for instance, in Vancouver, they're building temporary housing that really only has 20 to 25-year lifespan, meaning we're going to build that building 3 or 4 times over, and that's not cheap, that's really expensive. And if it's not maintained, that's even more expensive. But there's more to dignity than that. If you do not feel a sense of belonging, you do not feel a community connection to others in where you live, and you feel like you're being treated, and of course this image is about the worst of the worst, but like cattle, it starts to make you feel less valued by society. And those feelings result in true cost to society, and kids not going to school as much, people not going to work as much, people not feeling as productive. And at the end of the day, governments need to understand that these things, the cost of dignity, ends up in the bottom line of GDP. It's not free to choose the lowest cost housing. It actually costs us a fortune, but we don't measure it and we don't put a value on it. And as a result, we're not seeing this full picture and providing the best quality housing we can possibly provide. Now, there are countries that do it, but very few. So let me give you a few more examples of performance cost. And again, I'm just going to slice these tiny examples just to help us relate, right? Why does this matter? It matters because we're not innovating solutions, because we're not paying for solutions directly. And the industry won't solve things that they don't have to pay for. So when it comes to performance, there's a whole bunch of different types of performance issues that are impacted, and I'll kind of speed through them and just give you an example. So this one we can all relate to. So it's kind of like sound. Sound's an easy one to relate to. We all deal with it all the time. Well, we all deal with road closures. So when you choose to build a building, you have different techniques you could build a building with. The way we build buildings with using these mass timber panels and all these wood buildings, it's actually quite fast. We can shave months off the construction time. But if you choose to build in another system, you can shut down a road during construction for a year, maybe two. And all of us know what that feels like as we move through a city that's got road closures. I mean, obviously, we're repairing road is another version of this. But just for building a building, we're shutting it down. But all of us have probably had the experience of walking down a street with the hoarding that's protecting you as the crane goes over and seeing these poor businesses that are along that street that are struggling to stay open. And maybe they're not keeping the same staff on board and having to lay people off. They are not compensated for that time of construction. That building that chose the longer duration of construction actually doesn't compensate that individual business owner or the person that lost their job. But imagine if they did. They would make a choice to use the least impactful types of construction and would innovate to have the least impact on others, and currently they're not incentivized to do that. And that's part of the problem. But there are other aspects, right, that we all experience. Road closures impacts our time. Maybe it takes longer to get to work. Maybe you're late to pick up your kids from daycare. It has a huge impact on all of our individual lives, and we're not compensated for it. Sitting in traffic because of road closures and having to move around has higher traffic emissions. That's a cost from a climate point of view. All of this equals stress, and stress starts to impact every part of our life and even our relationships. That's all part of total cost. And none of it is part of the conversation of how we think about buildings and how we think about their impact. And again, without actually applying these costs, we're not going to see innovation. So I'll give you an inverse example of this. Because we build in wood, we build with natural materials, we really believe in this concept of biophilia, and you probably have heard of this. This is bringing nature into the environment that we live in. It actually reduces stress, and it actually increases productivity. So we're working with a high-tech company. This image, by the way, is a university, not that company, and I'm calling it Company X because we're not allowed to say who they are. But when we looked and talked to them about it, we really studied this idea that if they had 1,000 employees working in a building surrounded by wood products, and their salaries are very high because it's a tech company, and we just simply reduce their sick days by 5 to 10%, times all of that salary and all those productivity work days, starts to add up over 10 years to a huge number. And that number, which is the inverse of the last number, which is a true cost, this is a number of savings towards true cost that should be considered and currently isn't. So when somebody says, is that building more expensive? When I propose a wood building, it may be in traditional means, but when we start to add these other factors of true cost, it becomes a lot less expensive. And that's why it's important to talk about them. So the last piece I'll talk about is process. And process is really an interesting one because, as I said, productivity in this industry has gone down every year. We're really good at adding to the process. We're not really good at taking away the process. And process, I was trying to think of how to tell this story, and this is what I came up with. So many of you will hopefully recognize this building. This is called Falling Water. It was built almost 100 years ago. And it's designed by Frank Lloyd Wright, one of the great architects of arguably all time. And Frank Lloyd Wright, when he drew this building, only needed 13 sheets of paper to draw this building for the contractor to build it. And in those drawings, that included custom furniture. It included a super cool new electrical concept of 2 wires, and all this information to build what is considered one of the greatest houses ever built. Today, if Frank Lloyd Wright tried to do this, or somebody in his place tried to design the same building, he would use all the new software tools, all the new 3D modeling tools, probably some of the new AI rendering tools. He'd probably create a drawing set of 100 sheets of paper and a book of specifications that has testing requirements and testing reports and very specific information about every single material that needs to go into the building. And by the way, wouldn't be allowed to build next to a waterfall because it's too close to a water system, so we wouldn't see this building. And at the end of the day, because of the cost of all that mountain of paperwork and process and regulation, would probably not be able to afford to build the same building because that process takes away from building architecture. We're really good at adding time and process, but not actually making life better for the regular people that need these buildings. So the reason this is relevant now, that's the question, right? So a lot of what I'm talking about is very complicated. It is very difficult to put a price on human dignity and really completely unrealistic to do so up until now. And truthfully still now, but I believe in the near future we're going to be able to change that. And the reason we're going to be able to change that is much of this mountain of evidence that tells us, like that statistic at the beginning about lives impacted by sound, is available information, but it resides siloed inside of health departments, inside of ministries of education, ministries of environment. Inside of these different departments all over the world, there's mountains of data available that allows us to boil down what is the actual direct cost of these issues on the development of a single project. And with the AI tools that we're gonna see increasingly over the next 5 to 10 years, we're gonna be able to actually start to create transparency of these costs so that they're not costs paid for by all of us, they're costs assigned to specific building projects. And that when they are, that means we're gonna find ways to get rid of those costs by innovating and solving the problems that we haven't solved for a century. So the change is AI. And if you're listening to me and you're a bit horrified, and if you're a builder in here or a developer in here, you may well be a bit horrified that I'm gonna add to the costs of your buildings. Again, the point is not that, it's that we are all paying these prices already. We are, as society, paying for things and not solving them. And we have to find new tools to incentivize innovation to solve them. And so, sure, if you want to build a higher carbon building that's going to impact the planet, you can do so, but you should be accountable for that choice. Or if you choose to build with a better material, you should have that cost benefit of doing so. Those are the things that motivate change, and they're missing from our system. So the goal here is clearly about innovation. If you assign costs and transparency, you create innovation, but the other goal here is this last piece, which is that because our industry is one of the largest economic footprints on the planet, it also means that this is one of the biggest economic opportunities and investment opportunities in human history. It is a far bigger issue to solve some of these major problems in construction and design than the entire software industry. But right now, there's very little investment happening in this community and in this realm of innovation, and that obviously has to change. So I'm going to conclude with just a little example to show you that that change is possible. And I'm going to go back to sound. So I mentioned the first tall wood building was built by my good friend Andrew Waugh. This is also one of his projects. It's just finished in London, and it's built entirely in timber, and it's called the Black and White Building. It's a very lovely building, but when Andrew told me this story, that next door to that building is a very well-known recording studio called Strong Room Studios, where you can see the bands that once recorded there. And they were horrified that next door, this big building was going to get built, and they, was going to shut down their business if they couldn't obviously record from the noise. And so Andrew and the building's owner said, listen, we'll build this building, and we promise we'll never go above 36 decibels when we build this building. And if you know anything about sound, that's very little. In fact, that's the ambient noise in London on the street, right? That's just it. And they said, no, we won't go above that. And to help, they put this thing, it's a bit hard to see in this image, but that pole there has 2 solar panels on it and a light on the top and a sound meter on the side of it. And anytime they went above 36 decibels, that light would go red on the top. And it never once did. The industry will tell you change can't happen, and it's not true. It's incentivizing change that needs to happen. So my goal and my hope through this is that we introduce this concept to the world that we need to move away from just project costs and start talking about total cost, that we need to bring together data scientists, AI experts, climate experts, building experts, sociologists, and so forth to build this database of true cost. It is a very complicated thing to do. AI will help us do it. But if we do it, the question will no longer be, is it cheaper? It'll be, is it the true cost? And that's it. Thank you.